Hello everyone, so welcome to my YouTube channel. So it's been a long time that I have not given any video, so sorry for that. So here comes one of the a trick or a method to find out the period, group and the block of a given element. So one or the other question will definitely appear in your competitive exam, like CET, NEET, okay, to find out the period, group and the block of a given element. They're going to give you the electronic configuration and they'll tell you to find out which group, which period and which block the given element belongs, okay. So for that, the basic the simple trick is there, okay. If you remember those things, then it will be very easy and within a short time you can find out the period, block as well as a group, okay. So many of you have gone through already about these things, but still I'd like to say once again, okay. So see here how you can find out the period. So as you all know, like in your periodic table, how many periods and how many groups we have? Yes, so there are 7 periods and the 18 groups you have, right? So what happens? So how you can find out if the electronic configuration is given, how you can find out the period? So it's quite simple. When the electronic configuration is given, if you go through the principal quantum number, so I have not written a number here, okay, it's a principal quantum number of the valency shell, okay. I'll give you examples. I'll solve the examples and it will get crystal clear for you people, okay. So principal quantum number is nothing but the n value, okay. So which n value you will going to see? The valency shell. What is valency shell? The outermost shell that we have, okay. So you're going to observe that configuration and you will going to see the principal quantum number of that valency shell, okay. So I'm going to apply this in an example, then you're going to understand, okay. Next comes block. So as we all know, a periodic table is classified into 4 blocks, that is S, P, D, F block. Agree? So on what basis we are classifying it as a SPDF? So it depends on the outermost electronic configuration, okay. When you write a electronic configuration where the outermost electron present or belongs, okay. So the configuration is ending with a which orbital, okay. If it is a S orbital, then S block elements, P orbital, P block elements, D orbital, D block, likewise F orbital, F block elements. That is the type of orbital which receives the last electron, okay. Now comes the group, okay. So there are 18 groups as we all know. So how are we going to calculate the group? By seeing the electronic configuration. So it's quite simple. See, in general, it's a number of electrons in the valency shell and the penultimate shell, a shell before the last one, okay. The number of electrons in the valency shell, that is the outermost shell, how many electrons are present, and before that how many electrons are present, so, okay. So this is a general what I can say, the rule. But when it comes to S block, P block, D block, okay, likewise the F block, what happens? The different rules you need to apply in order to find out the group, okay. So how? See here, for the S block elements, group number, how we going to calculate the group number? As you all know, S block elements are present in the group 1 and group 2 of your periodic table, okay. So how we going to find out? What you are going to see? You will going to see the number of valency electrons, okay. When the configuration is given, when the atomic number is given, when you write the electronic configuration, what you going to observe? The number of valency electrons, okay. If you observe the number of valency electrons, that decides whether it is a first group or second group element or it's a S block elements, okay. We will going to apply this, we're going to see that, okay. Now for P block elements, how we're going to calculate the group number? It is 10 plus number of electrons in a valency shell, okay. So for B block elements, 10 number you had to add. To that you had to take a number of electrons in a valency shell. Okay, 10 plus number of electrons in a valency shell. Okay, that's for a p block elements. Now in case of a d block elements, how will going to calculate the group number? It is the number of electrons in a n minus 1 d subshell. See, we will going to observe the outermost configuration. We will going to see the outermost valency shell and the number of electrons in a n minus 1 d subshell plus number of electrons in a valency shell, n and n minus 1 shell and the penultimate shell. So those two shells number of electrons are added, and by that we will going to find out. Okay, so these are the rules to find out, and it's an easy way to apply or to find out the period, group and the block of a given element. So fine. Now let us take some examples and apply all these rules. Okay, so let us consider an example. For example, yeah, see here, I'm going to write one configuration like 1s2, 2s2, 2p, which one shall we take? 2p, 5. Okay, so this is the configuration. Let us imagine. So now, so what you're going to, you have to find out the group. Okay, you had to find out the period, you had to find out the block, and you had to find out the group. So let us find out all the three. Now see here, for the period, okay, we need to find out which period does this this configuration belongs, and we will going to observe the block also. Okay, so what are the rules that you will going to apply here? See, in order to find out the period, what you will going to see? You will going to see the principal quantum number of the valency shell, dear students. So principal quantum number, so always you have to observe the outermost configuration. Okay, so now see here, this is what the outermost configuration we have, and what is the principal quantum number we have? That is a shell, main shell of an electronic configuration where the electron belongs. So what we have? 2. So n value is equal to 2 means this configuration or this element belongs to which period? The second period of your periodic table. Okay, so one value you got to know. Now how are we going to find out the block here? Type of orbital which receives the last electron. So what you are going to see? You will going to see the outermost configuration. So now 2s2, 2p5. So what the orbital you have at the outermost configuration? P orbital. So dear students, the block is p block elements. Okay, so this configuration or this element belongs to which? It belongs to a p block. Okay, now which is very important part, that is a group of an element you need to find out. How are we going to find out the group? See, quite simple. Once you got to know it's a p block elements, okay, so you should remember what is the rule that you're going to apply for the p block elements. So how are we going to find out the group number? 10 plus number of electrons in a valency shell. Okay, so dear students, so here 10 plus number of electrons in a valency shell. So where we have a valency shell? 2s2, 2p5. Don't get confused and don't think that only 2p5 is the valency shell. No, both have the same quantum number. Both belong to the second shell. Okay, so obviously 2s2, 2p5 both are in the valency shell. Okay, so 10 plus total how many electrons we have in a valency shell? 5 plus 2, 7. So 10 plus 7 is 17. So dear students, the group where this configuration or the element belongs to is a 17th group element. Sure? Okay, 17th group element is which group? It's a halogen, as we all know. Okay, it belongs to a halogen family. So you could see here 1s2, 2s2, 2p5. Total what is the atomic number is 5 plus 2, 7, 9. 9 means it is fluorine. Okay, so this is how you can apply and how you can find out the period, the block and the group of an element. Okay, so let us take one more example. So just a minute, I'll take an example and we're going to solve that. So let us take one more example where let us take a atomic number 12. Okay, once the atomic number is given, obviously you should know how to write the configuration. So 1s2, 2s2, 2p6, 3s 2. Agree? So 6 plus 2 8, 8 plus 2 10, 10 plus 2 12. Yeah. Now again what you need to find out? First thing, period and the block and the group, dear students. Okay. Now once you get to know the period and the block, finding the group number will get easy. Okay. Now the period. So what are you going to observe to find out the period? We will going to observe the principal quantum number of the valency shell. So what is the principal quantum number we have? We have 3. So obviously n value is 3 means this element belongs to a period 3. Okay. Now a block. Again what you're going to observe? You're going to observe the orbital of a valency shell. So valency shell has got a which orbital? S orbital. So which block element, dear students, it is? It's a S block element. Okay. Now, which is a very important, once you got to know it's a S block elements, we're going to apply the rule for the S block elements to find out the group. So what are you going to see for the S block elements? What we have? Number of valency electrons, dear students. Okay. So now, this is a valency shell. So how many electrons we have in a valency shell? 2 electrons. So obviously the group number will be how much? 2. Okay, yes. Now you can guess. So 12 is the atomic number, means it's a magnesium, dear students. You can check the periodic table where exactly this magnesium belongs. Okay, it belongs to a group number 2. Okay, so this is how you can find out. You can apply the rules. Okay, clear? I hope you have understood. The thing is, when you go on solving so many problems based on this one, then the finding the period, block and the group becomes very easy. Okay, I hope you find this video useful. If you have any doubts regarding other concept which you want me to do some videos, please do comment in the comment box. Okay, yeah, that's it, and I hope you find this one useful. Thank you so much.